Yeah, it works.
Okay, perfect. Sorry. So, all right. Back on track. No. Here we go. So, other questions, and then we can start. If not, we can start with discussing this association of dipole. No extra questions?
No.
Okay, for now. So now back to the test form and how to handle these circuits. So in fact, these test sheets are exactly the same kind of exercise we're going to do today. So we're going to spend some time on this. So let's start with the first example. We do have this association. Okay. Sorry, it seems that. Can you hear me now?
Yes.
Sorry, it's super disappointed. So, so you have this kind of circuits. The idea here is what is resistance, the equivalent resistor between B and D. I take
Excuse me, can you share the screen again?
Sorry?
We can't see your screen.
All right, so I'm back and I put my computer on its station. So now I have a stable connection, but no tab. So no tablets. So we're gonna find a way of work, and I'm gonna use my camera, except if you do have some clues, or maybe I can. It's gonna be super bad, but let's see what can I do here. Let's see here. Partager. Can you hear me well and see my screen now?
Yes.
Cool. So I'm gonna use my super mouse skill to make the drawing now. So I hope it's gonna be clear enough. Sorry for the inconvenience, but okay. So back on this, I had this node here, which was D. I can extend a wire here if there is no thing in between these 2 points. It means that they do have exactly the same potential, right? Same thing here. Yeah, not bad. So this could be B, and also this could be D, right? So then the question is, okay, there is some current flowing here, correct? Because of the node law, it's going to be divided into two currents. Oh, it's super crappy, but sorry. I1 and I2. All right. Then the question is how this current then is going to flow through my circuits. This current is going to flow also through this resistor, right? Since these two resistors here, so it's 1, 2, 3, and 4. So this current I1 is flowing through 1 and through 2. There is no dot. These two resistors are in series, which means that this could be a unique resistor, which is 1 plus 2. Same here, I2 flowing through this and this. You can combine these two. This is 3 plus 4. So if you want, you can redraw the full thing. So you have here, point, a resistor here. Sorry, super fancy. There you go. So this is 1 plus 2, and this is 3 plus 4. So now you come back to a situation where you have two resistors, and because also of the node law, the current here is going to be separated into two, I1 and I2. And you don't have the same current flowing through these two resistors, which means that this resistor is in parallel to this resistor. So at the end, the result is 1 plus 2 in parallel with 3 plus 4. So then if you go back to Elec, B and D, product of a sum, so it's 1 plus 2, 3, this is a bracket, plus 4, over the sum, 1 plus 2 plus 3 plus 4. All right?
Yes.
Okay, so I'm not gonna go through all of them, but if there is a specific need for me to discuss another example in particular, please let me know. Now? Is it okay?
Yes, please. Can we check the last one? Because
The very last one?
yes, please.
With the 4R, 2R, etc.?
Yes.
Okay. So I'm gonna try to use my super skill. It looks like my kid is drawing. So let me check. R. Then you have this. I'm not gonna do the full thing. 4R. 4R. 2R. And this is up. These two are connected here. Here you go. Then you have this R here, so it's R. Then R here, and then 2R here. And then point here and like this. Sorry for the quality of this drawing, but again, doing my best. So when you start with a circuit like this, the idea is to see which nodes are the same, which resistors are connected together, and which resistors are in series or not. So don't hesitate to redraw this using other direction. Okay, let's see if I can redraw this like this. So you have one R here, which corresponds to this one. Then this point, and this point, in fact, are the same node. Okay, there is nothing between these two, so I can fuse them. Same here for these two. So you get this 4R here, 4R here, and 2R here. And same thing. Oh, man. These 2 points, these 3 points, you can fuse them like this. Then you end up with 1R here. Then you have a node, and then you have a R, and you can put B here. This is the point B. This is the point A. And we are missing now one resistor which goes from here. So it's 2R to there. Okay, so this is just a redrawing, a bad one, but a redrawing of these circuits, but in another direction. And from here, the first thing is to detect, could you already see some resistors that are in parallel or in series? The question is it easy to detect them or not? And do you clearly see already some association, easy association? The answer is
the first
yes.
and the last R.
Yeah, these four and these 2R, these 3 resistors, they share their terminals here and here. So these 3 are in parallel. All right. So again, to help you, especially at the beginning of this class, feel free to draw a lot, and you have here an equivalent resistor, which is 4R parallel to 4R parallel to 2R. This is disgusting. Then R, then 2R, and then this is back here. All right, and we go through this step by step. So this is now your new kind of configuration. Could you see association of resistor? Just a point here. You cannot say that this 2R is in parallel with this single R here. Why? Because they don't share both of their terminals. This is the case here. They join their terminals here, but not here, because you have this in between. Okay, so what you're going to do is it working? Come on. Red, good. So you are going to say that these two here are in series. Why? Because you have some current entering here, spreading between this branch here and this branch here. But as soon as it entering in this resistor, exciting this resistor, entering this one, the same current is flowing through this branch, which means that both of these resistors are in series. And little by little, you're going to simplify your what the heck? Can't find. Give me black, simple black. There we go. So little by little, you're going to simplify this, which is R, then the sum of these two, which is going to make a unique resistor. Let's call it R Ec. Then you have 2R here. And an extra R here. Again, because of the simplification of your scheme, then you can tell that these two here are in parallel. So again, next step, your R plus R Ec in parallel. Oh, come on, parallel is not. Parallel to 2R. Here we go, and then you end up with these three resistors in series. Is it clear?
Yes.
Yes.
And we're gonna practice this today with the exercise of the, so you go now back to the dipole exercise number 2 of your exercise sheet, and you go through this exercise and try to find each time the equivalent resistor between A and B. So you can play with resistors and try to find this association. So please go for it through this exercise number 2. Take a white sheet of paper, practice it, and of course I'm going to give you each time the final answer of the requested resistor seen between A and B. If someone already have a result, please feel free to share it. So in the first case, circuit 0, optical illusion, or the resistor equals to R, right?
Excuse me?
Yeah.
Can you explain for the first one why they are parallel, please?
Try to, before explaining you exactly how to do, try to practice them a bit and try to see which resistors, if there is some resistors that can share their terminals, and if you check which points correspond to, or if you can fuse some nodes, then you're gonna find the result little by little. Okay, so try to spend a bit of time, try to find this solution before me explaining it to you. If not, you won't be able to solve it later. So try to redraw the scheme you have by, for instance, moving the resistors along the wires, and see if then you can draw the circuits in a way which is going to be clearer for you that all of these three resistors are in parallel. And of course, I will, after a while, give you some clues. But now, please practice. This is for you. This is hard work for you, but you have to practice. Try to draw, and then, of course, I will give you some clues.
Excuse me.
Yeah.
I have a paper that has like very difficult circuits. I mean,
Yeah.
hard to understand. Like it's like Poupée Russe and Made in Prépa.
Yeah.
Are we gonna see those two because they're like, I can't understand.
We are doing them right now. So right now, I'm gonna give you just the solution of this result, the result of this circuit. So sorry, this is the first circuit, but this corresponds to the circuit 0. This is corresponding to the Russian-Doll-Poupée Russe result. And then I'm going to give you what is the use of the wire, well, made in Prépa.
Okay.
I'm going to give you the clue each time, but you have to practice them.
Yeah. Okay.
Okay.
Mm-hmm. Thanks.
Sorry, it was not. This is a bit confused. So this is circuit 0. This is actually circuit 2. So Russian doll, in fact, it's so simple that I haven't write the results. So I'm going to do it quickly right now. Oh yeah, maybe this is quite interesting for you, a quick way of solving resistors that are in parallel. If, well, maybe you already noticed it, but if you have 2R in parallel with 2R, the result is 1R. So it's one resistor divided by 2, in fact. So when you have 4R in parallel with 4R, the result, the equivalent resistor is 2R. This is very useful in the case of the Richendell problem, that you have to deal with this circuit from right to left. So let me just give me a moment to give you the result of this. Donc R, 2R, donc ça fait R, ça fait 1 demi de R, donc ça fait 4R plus 0,5R, ça fait 4,5. All right. So should be something like 4.5R. All right.
Sorry.
Yep.
I don't understand why when it's 2R in parallel with 2R, it's 1R.
Sure, let's do it quickly.
Isn't it 2R times 2R?
Yep. So it's 2R. Oh, sorry. No. Yeah, I'm confused. Sorry. So 2R times 2R makes 4R to the square. Okay.
Yes.
Over 4R. Then the result is R.
Oh yeah, thanks.
Make sense? So as soon as you have two resistors that are equal N in parallel, then their equivalent resistor is half of one of them. But if you don't remember this, that's fine. Just demonstrate it like I just did. And for so C3. It's 5R. So to deal with this exercise is the circuits, the idea is just redrawing, in fact. Redrawing, pulling wires if it's not creating any other question, well, you can add a wire in between nodes or from nodes to help you solving, like I did previously when we were discussing this diamond thing with the resistor here. Just to help you, here you have a node, and if the question is what is the resistors between this node and this node, then of course you're allowed to add some wires here. It's not changing the circuits, and this point here has the same potential as this point. So in fact, it's kind of an extension of this node here, and maybe it's helping you seeing which resistors are in series or in parallel. So this is just a redrawing of the first circuits. Just put the resistor maybe in another orientation that maybe gonna help you see what's going on. So from here, and even from your let's say from the document of the exercise, that this is another way of drawing the circuits, but they are completely equivalent. And but maybe from here, or even from the scheme of your exercise, you can detect that these two here are exactly the same node. Between A and D, I don't have any resistors. So in fact, and same here. So in fact, this is equivalent of R, 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 here a single node, here another single node. I can call this node D, comma A. Same point, they do have the same potential. Same here between B and C. Okay? And this is quite simply to get after and see that now these three resistors are in parallel. Of course, you can extend this here, extend this here. So you can practice this in the test form, practice this here with these circuits. In the last circuits made in Prepa, then you can practice the equivalent resistors between different terminals. So this is the answer for A and B, but of course you can go between C, D, E, F. Actually, this is the, it's not between A and B because it's asked between C and D.
I didn't quite understand why the result is 5 on the circuit number 3.
Okay, let me double check. So,
From point A to point B, I mean.
Let's see. Here between C and D, just give me a sec. So between C and D, so you just quickly redoing the calculation just to double check if I haven't made any mistake. So it's 2r plus r plus 3r, which makes this is 5r. No, this makes 6r. Then total 6r. Then sorry, it's not between C and D. It should be in between A and B. And yeah, well, maybe it's still puzzling you why it's between A and B. You can't find this result, correct?
Yes, I want to know how we got to this result. Like, why is it 5?
Okay, so again, let's try to redraw the full thing. Let's see. Is it okay if I raise this?
Yes.
Yes.
Okay.
Yes.
All right. So let's try to redraw the full thing. So here R. So this is A. This is R. Then this is C. From C to G, sorry, I have a node. I have just a wire. Then I go to E here. Between here, 4R. I have another 4R here. I'm very sorry for the drawing. Then A, then you have R. Then you reach F. Then you have 12R here. 12R here. You have a 6R here. Oh, come on. Super shitty, I'm sorry. Again. This is connected and this is connected. So here you have D, point D. Here you have H. Here R. And here B. Whew. Are you okay with this redrawing?
Yes.
Okay, so now the idea again is to see which node might be fused or not. And this is going to help you a lot. And you can see that now these two can be fused. They are the same, they are linked by a wire, which means that they do have the same potential, and same here. Okay, so again, I'm going to try to mix and redraw the circuit. So now you have this point, which is now C, comma G. From this guy, you have 4R here, 4R there. That meet here at E. Then you have R. Then again 6R, 6R, took. Then you have here 12R and 12R, and everything is meeting here at the node that I can call now D.H. And then from this node, you have another R, and you have E and B. Okay? And now the question is detecting resistors in parallel and series. Again, you cannot say that these 12R resistors are in parallel with this guy, okay? So start little by little. Here, what you are doing is saying that these two are in parallel. These two are in parallel. So this makes 2R. This makes 3R. Then you take, change color. These now 3 resistors are in series in this branch. This new branch is 2R plus 3R plus R, which makes 6R. So you have 6R, 12R, and 12R. All starting from the same point and arriving at the same point, which means that these 3 resistors are now in parallel. Start by doing these 2 in parallel, you end up with 6R. So if you just take this guy and this guy, they are in parallel, and this is gonna make you 6R, correct? Then you end up with 6R in parallel with 6R, which makes 3R. So all of these could be simplified into a big 3R resistor. So then you have R in series with this huge resistor that it is again in series with this resistor here. So 3R plus R, which makes 5R. Sorry, it's super crappy. I hope it's clear for you, at least.
No, it actually made way more sense. I just wasn't seeing it right. Thank you.
And I'm still struggling with the Russian dolls.
Okay.
That one's very clear, but the Russian dolls I can't.
Okay, so the Russian dolls, the idea is to start from the right part of the circuits, right? You can see that the only thing you can tell is that the 2R on the right side, they are on the same branch, correct? Which means that the current flowing through these 2R is the same. So you can add them since these 2 are in series. So it makes another resistors equals to 2R. So let me just maybe again use my super drawing skills. So I'm just writing the far right part of the circuits. So you end up with this by adding. So you add the 2 resistors which were previously on this branch, correct? And that makes you 2R. Then you see that these 2 resistors share both of their terminals, which means that now they are in series, in parallel. So these 2 now is a single R, okay? So it's a single R, then you have a 1.5 R here, 1.5 R there, Amen, R, and here another 2 R, and then the rest of the circuits. So same thinking, these 3 resistors are now in series, which is going to make you another 2R resistor, equivalent resistor in this branch. You are back to this configuration. So you start, in fact, packing, contracting, I would say, the circuits from right to left, and little by little, you will end up with the final resistors, and that you have to add with the 2R on each side. Does it? Is it?
Yes, it's yeah, definitely. Thank you.
Okay, perfect. So again, it's practicing and practicing and practicing. You can find other example on the internet, on the books I mentioned in the class document, on the test forms, and that's it. What else can I do? Yeah, if you want the result, let me go back here. The results between, so the equivalent resistor seen between E and F on the Made in Prepa circuits, and you should get something like R parallel to 11R if you want to practice. Again, same circuits, but a different resistor. If you have questions, if you want me to detail some part, feel free to let me know.
Could you draw for the circuit 2?
Yeah. So circuit 2, yeah. To try to redraw it. Let's see. I'm gonna do my best again. So yeah, this is actually something which is puzzling just because of the way it's drawing, but it shouldn't be. If you try to make these circuits real in front of you, which is using, let's say, pen to make resistors, and then try to connect them with wires, then you have kind of a free wires, which is the wires you have on the left part of the circuits. So I don't know if I'm super clear, but you have one resistor here connected to another resistor here. Then you have another resistor here and another resistor here. That's it. So in fact, you start from here with these 4 resistors, and then you have these funky wires which was added here. But it's like, if I want to redraw it, and if you try to materialize it by a wire, it can be, it can fall down on the left, but it can fall actually in the middle, let's say. Here, this node here is the same than this node here, correct? Same here. So when I add an extra wire like this, it's like letting the wires down, which is equivalent to this. Do you agree with that?
Yes.
Okay. So instead of, let's say that this is a physical wire, instead of leaving it from or following it on the left side of the circuit, I just leave it in the middle. But it's exactly the same. But then one thing you can say is that actually these 2 points can be fused because they are linked by a wire. And so when you have this kind of configuration, then you can mix them, which actually end up with something like up, 1 point here, one point there. Okay. So then the question is between A and B. So between this A here and this B there. So let's rewrite the circuits again like this. Single node in the middle. There we go. Do you get it now?
Yeah, thanks.
So again, if you have a node, you can play with the node. From one node, this is equivalent to, of course, this. 2 nodes linked by a wire. So you can actually, you're allowed to fuse them to pull a wire between nodes. And so now you end up with something which is, if you want to play again, this is again another way of redrawing it. Sorry. So from this scheme, this is now simple to handle. You have these 2 resistors that are in parallel, these 2 resistors that are in parallel, and then you add them. Entrée. Are you okay?
Yes, thank you.
Then as soon as you simplify them, both are going to be in series at the very end. That's it. So we are now done with our session, our today's session. Again, practice the exercise. Try to play with the test form with the circuits from this sheet, you have all the answers to verify your result. So next time, so it's what? It's gonna be next Friday. I don't know. Let me check. Agenda. So the next session is next Wednesday. Next Wednesday is going to be an autonomous session. Again, we won't meet. You are going to have this free time to go up to page, let's say 19. Try to do the test form 4. And also you can have a look on page 29, which is another theorem. And so, so this is for you the next session on Wednesday 9. We won't meet, but we will meet the next time next Wednesday 11th morning. And so for this session, we will discuss the next exercise in the exercise booklet. All right? Do you have questions?
No.
No.
Okay, brilliant. Sorry for the disconnections and internet problems. I hope I'm gonna receive the adapter soon, so I'm can make this class in better conditions. Have a nice week, and we will meet next Friday morning.